Hello everyone, this is the last session of our topic. In the previous video, we have discussed some of the application and simulation emulation tools of SDN. Today, I am going to give you a brief lecture on SDN security. Outline of today's lectures is Introduction to SDN security advantages, security threats in SDN architecture. Network security is one of the most important aspects to consider when working over the internet, LAN or other method. And no matter how small or big your business is, network security is important for home network as well as business world. Most homes with high-speed internet connections have one or more wireless routers which could be exploited if it is not properly managed. Network security today is clouded in more complexity than ever. In SDN environment, SDN network security needs to be everywhere within the software-defined network. SDN security needs to be built into the architecture as well as delivered as a service to protect the availability, integrity and privacy of all connected resources and information. Within the SDN architecture, we have to secure the controller as a centralized decision point, as the SDN controller needs to be tightly controlled. Suppose if the SDN controller goes down because of some reasons, then the entire network goes down. Then the availability of the SDN controller needs to be maintained. We have to establish the trust. So protecting the communication throughout the network is critical, but we have to ensure the SDN controller, the applications loaded on it and the devices it manages are all trusted entities. The next, we have to create a robust policy framework, which means that when an incident happens, you must be able to determine what it is, recover as soon as possible, report the incident and then protect it against in the future. The last, we have to conduct forensic and remediation. What needed is a system of checks and balances to make sure that the SDN controllers are doing what we actually want them to do. The next we are going to see is the advantages of SDN security. The structure of SDN environment brings a great benefits to the networking scheme. Now I am going to focus on those benefits related to security. From the network security perspective, there are three core characteristics that differentiate SDN networks from the traditional ones. The three core characteristics of SDN related to security are global network view, self-healing mechanism and increased controlled capability. The controller in the SDN platform has a global network view, which is attributed to centralization and to the fact that all the elements in the networks are collecting and reporting traffic statistics. The security advantages that the global network view brings to the SDN environment are network-wide intrusion reduction and detection of malicious switch behavior. Intrusion reduction system is a device that is usually installed on a certain part of the network. The SDN controller usually runs the IDS, which analyzes the traffic statistics collected from all the network devices in order to detect malicious traffic. SDN controller provides limited detection capabilities because it has limited visibility. After collecting traffic statistics from the SDN switches, there are two ways to operate the IDS. The first one is misuse detection. It is based on the idea of building a profiles called signatures for known attacks. The behavior of the network is monitored constantly and an intrusion is reported if the monitored behavior matches any one of the signatures. The next is anomaly deduction. The network traffic is profiled when no malicious activity is going on by basically capturing the general characteristics of the packet originating from the trusted hosts within the network while running the trusted applications. An intrusion is reported if the network behavior deviates significantly from those profiles. Each one of those two deduction mechanisms have both advantages and disadvantages. Researchers are still investigating improvements for the IDS framework. SDN with a special focuses on reducing processing overhead, increasing detection accuracy and making the framework adaptive. The global network view also helps in detecting network switches malicious behavior. When compared to traditional method, it is easier in SDN environment to detect the malicious behavior of the switches because switches periodically reports its status such as number of packets received, dropped and forwarded packets to the controller. controller. By analyzing these reports, the misbehaving switches can be identified, or at least the list of suspected switches can be narrowed down. The next advantages of SDN environment is self-healing mechanisms. Conditional rules are the examples of self-healing mechanisms which is introduced in SDN environment. These rules are installed on the switches by the control plane, and the switch should respond when a specified condition is met. The reaction of the switch could be to drop the packets specified by the rule, or to modify the header part of the packets to redirect to a honeyspot. Here the honeyspot refers to a host which is used as a trap of information about a malicious information. The next, increased control capability is the last SDN environment advantages from the security point. SDN networks have more control capabilities when compared to traditional networks. The multiple header fields in the packets helps the controller can have better access control by specifying what type of packet should be routed through this network. This helps in limiting malicious traffic initiated to and from any switches in the SDN. Increased control capabilities is the last SDN environment advantages from security point. SDN networks can have more control capabilities when compared to traditional networks. The multiple header fields in the packets helps the controller can have better access to the controller by specifying what type of packet should be routed through this network. This helps in limiting malicious traffic initiated to or from any switches in the SDN environment. Now we are going to see the core part of our topic, SDN security threats. The basic properties to build a secure communication networks are confidentiality, integrity, availability of information, authentication, and non-repudiation. In order to provide a network protected from malicious attack or unintentional damage, it is important to secure the data, the network asset, and the communication transaction across the network. The alteration to the network architecture introduced by SDN can be accessed to ensure that the network security is sustained. Now we are going to see the different types of security attacks and threats exist in SDN platform, and on which part of the SDN architecture the security vulnerabilities are targeted. From a basic point of view, to build a secure SDN environment, it is essential to ensure the security of each and every layer in the SDN architecture. The layers are application layer, infrastructure layer, and control layer. Application layer security challenges. Most of the network functions can be implemented as SDN application, so have to analyze malicious applications and take necessary precaution early enough from spreading over the network. There are no standards or open specification to facilitate open API for applications to control network services and functions through the control plane. Applications can pose serious security threats to the network resources, services, and functions. The variety of third-party applications developed in different independent development environment using different programming models and platforms could create interoperability limitations and security policy collisions. Some of the threatening security challenges posed by SDN applications are authentication and authorization, access control, and accountability. Authentication and authorization. The control plane implements many applications from the application layer which are developed by third party. Authenticating and authorizing these applications will be one of the major issues in the SDN domains. These applications inherit access privileges of network resources and network behavior. It is a challenge to provide authenticating mechanisms for increasing number of applications in SDN domain to protect network resources from malicious activities. Many techniques exist to certify network devices in a network, but there are no mechanism to certify network applications. It is important to create a trust relationship between the controller and the application. Access control and accountability. We all know that the applications implement most of the network services in SDN. Proper access control and accountability mechanisms are essential to ensure network security. It is important to identify and understand the possible security threats related to access control and accountability in SDN. An example of such applications are network sensitive applications which need network characteristics. Load balancing applications might need network statistics. Applications that provide services for the network such as access control or firewall and content inspection or intrusion reduction. These kinds of user applications must be scrutinized properly before access to the network, but the customized security procedures based on the different categories of applications may not be demonstrated yet. The second layer in SDN architecture is control plane layer. Now we are going to see the security challenges in the control plane. Securing the centralized decision point of SDN controller is the top priority. The SDN controller is responsible for managing and controlling the entire network through the network operating system. Therefore, the controller can be highly targeted for carrying out malicious activities in the network. If any threat attacks the SDN controller, then the whole network gets failure. The main security challenges and threats existing in the control plane are threats from applications, DOS attacks and DOS attacks due to multi-controller. Threats from applications. As we have discussed previously, applications implemented on top of the control plane can create serious security threats to the control plane. The controller should have the capability to authenticate the applications and access the network information and authorize the resources used by the third-party applications. Different applications having different functional requirements from the control plane and data plane should scrutinize carefully to qualify customized security requirements. The next is DOS attack. The DOS attacks and the distributed DOS attacks are the most threatening security challenges for the SDN controller. DOS attack is an attempt to make the network resources unavailable to the legitimate users. The main cause for the malicious behavior of DDoS attacks are centralization of controller, more number of flows and limited storage capacity to store flow rules in forwarding table. The next is DOS attacks due to multi-controller. The forwarding decision of the network devices are taken by the logically centralized controller, which cause more complexity. The controller have to push flow rules to the network devices for each new flows. If there are large number of flows, leads to the controller becomes the bottleneck. Thus, the increasing number of flows makes the increasing number of flows makes the SDN environment a single point failure and chance of DOS attacks. To avoid this failure, multiple controllers are recommended, but the use of multiple controllers is not the solution to the DOS attacks since it can lead to cascading failure of multiple controllers. The last layer is the infrastructure layer. In SDN, the control plane directs the data plane to process the incoming packets by pushing flow rules. These rules can be stored before or after host sender packets. This communication opens the door for the attacker to inject new threats to the network. The main goal of the SDN architecture is to separate the decision-making capability from the network devices, which cause two security challenges. The first challenge is to distinguish valid flow rules from the malicious rules, and the second challenge is a limited storage capacity to store the number of flows in flow tables. By using this forwarding switch, attackers can do malicious activities such as DOS attack, topology poisoning attack, and side channel attack. The denial of attack intention is to consume data control plane bandwidth, SDN controller resources such as CPU memory. Attackers use some botnet send packets to switch by creating false packet from existing packets to deny the data path. These packets won't match with the existing flow rules. So when the controller insert the flow rules to manage the traffic, the storage of switch flow gets overloaded. Topology poisoning attacks. The network information collected by the controller could be destroyed by the attackers. The attacker first observes actual link layer discovery packet to collect the LLDP format. Then the attacker may either modify the content of the LLDP or send the same LLDP to other hosts, and those LLDP sent to the controller to respond. As outcome of this, the link between two disconnected switches is created. This gives the way for the attacker to win the man-in-the-middle attack or deny some legal switch port based on the topology poisoning attack. As outcome, link between two disconnected switches is created. This gives the way for the attacker to the man-in-the-middle attack or deny some legal switch port based on the topology poisoning attack. In side channel attacks, the attackers extract the network configuration information by sending a stream of packets and assess the amount of time needed for control plane to respond OpenFlow switch to process the packet. Then the attacker compares the responding time of test stream of packets and actual packets. From this, attacker learn whether the network use OpenFlow, the switch storage size, host communication information, network monitoring policies, etc. The next we are going to see security issues in SDN. Software-defined networking environment continue to grow. Security is essential to protecting the availability and privacy of all connected resources and information. But securing SDN can be difficult. Regardless, the solutions needed to be designed to create an environment that is more scalable, efficient, and secure. Although SDN is not the solution for all networking challenges, it makes handling many common issues easier. By combining the security of cloud and the flexibility of one's own SDN network, it may be much easier to build a custom system that is clear of holes and updates with the latest patches. That alone boosts security significantly. Now we have come to the end of this lecture series. In this lecture series, we have 8 sessions in that you have learned the basic concepts of software-defined networks, SDN architecture, rule placement with OpenFlow, controller placement, network virtualization, application and tools of SDN, SDN security in a nutshell. I hope it would help you to get important aspects of SDN. Thank you.